Hi, I'm Christian.
And I'm Vera.
And in this episode, we're gonna assemble the short block of our SDV6 3-liter diesel engine, which is used in the Ford F-150 and in various Land Rover models.
Hope you enjoy the video.
So the idea is here to give the crankshaft a polish on all the mains and all the pin bearings. So I got like a stainless steel polishing compound here. So I put this on here, like this. I got a cotton rope here, really thick and heavy duty. So I'm gonna wrap it around here just once. That's looking pretty good, I think, compared to this one. So the big ends I gotta do by hand. Why don't you do that?
Yes. Oh, that is a great workout. You see, you don't need a gym.
Okay, you gotta pull it harder.
I'm pulling harder.
Good enough? Oh, look how that looks. It's like new.
You just gotta clean the fillet rolls.
This is the manual polishing procedure we use, okay? I supervise the procedure in detail. That's not good enough. You messed up on that one. Yeah, I got much more stroke than you do.
I want to get a machine like Dave has.
This is looking really good now. It's all clean. Gotta make sure I clean it here out of the fillets on the side. Okay, here I gotta clean out the oil bores now out of the crankshaft. You can see how the oil is delivered from the main into the conrod bearing here. What most people don't realize that on a 6-cylinder, the outer mains supply only one conrod bearing. The inner mains, each of them supplies 2 conrod bearings, okay? You can see that this main supplies this bearing and this bearing. So the oil pressure drop on this bearing is twice as high as on this bearing. That's the reason why typically the inner conrod bearings fail or the inner main bearings fail. They just have to live with half the oil. She said Dave is using compressed air to clean those out. So that definitely made sense.
Good.
This crankshaft in the SDV6 from day one in the TDV6 in the 2.7 liter in 2005 was already a forged, fillet rolled, hardened crankshaft, okay? It never was a cast crankshaft. It was always forged from the beginning. This parting line, if you have a cast crankshaft, is really small and narrow. If you got a forged crankshaft, it's really thick. So you can see immediately on the parting line if this is a forged crankshaft or not. The only thing Ford did is small revisions on this crankshaft. For example, they changed multiple times the width of this flat here, which drives the oil pump. Another thing they changed is the fillet roll pressure they used to do the fillet roll process here in the corners and also the fillet roll angles, okay? A fillet roll process basically takes the stress out of the edge of the bearing. You can have these bearing surfaces with a radius in it, or you can have them with a fillet in it, okay? The fillet is the weaker one, but takes less room, and that's why they roll it. They put a hardened steel roller into each corner, and they put under pressure while the crankshaft is rotating. And that's condensing the material and taking out stress. Why are you laughing? Did Dave say that differently?
No, if you don't have the fillet roll, the bearings overheat. Get hotter on the edge.
You don't want to confuse that with the bearings actually rolling up on the radius on the side. That heats up the bearing and they burn up on the edges, especially if they are not centered precisely. And in order to save room, you put a fillet in. A fillet takes out the entire edge and then your bearing can occupy more room in between your two lobes here. This is the reason why they do fillet rolling. It allows them to build the crankshaft shorter. And if we all know how short the SDV6 is, for that power what it delivers, it's unmatched on the market. I claim you do not find a 6-cylinder diesel engine where the block is actually shorter. And the compromise is pretty clear. It snaps a crank here and there, okay?
But only on 2%.
The other thing is these crankshafts are induction hardened, okay? And the hardening depth is only 0.5 millimeter deep. So it's not a really good idea to re-grind SDV6 crankshafts if you had a bearing failure. You may want to think about rather spending €1,500 for a new one. And the best crankshaft you can buy for your SDV6 is the Ford OEM. They did the latest revision somewhere in 2016, but to be sure that you have a crankshaft which has all the updates done to it from Ford, you should get one 2018 or later, then you're absolutely safe. The typical failure spot of this crankshaft here is between the first and the second main, in between the connecting rods, right here. Here, if you look at this lobe, how little material there is, okay? It's pretty obvious for everyone that this is not good for a crankshaft which can deliver 640 Newton meters of torque permanently, starting at 1750 RPM, okay? This is just too much power for this small of a package.
Very well explained. So Christian planned on not replacing the trigger wheel. I have taken out a transmission twice because we had messed up trigger wheels. And he wanted us to do it a third time. He does not learn from his own lessons.
Statistically, if we had two bad ones, okay, and I'm using now a used one, I'm statistically safe. It should work.
No, because every failure mode was different. We are not doing that, Christian. I made him order a new one.
I got myself Loctite 601, which is especially made to glue on trigger wheels like that. Plus, I paid attention when I took the trigger wheel off that I didn't destroy it. That would have saved me €156, but no, I had to buy one yesterday. Otherwise, we got close to a divorce.
It never fell out on us, you know.
That would be a new failure mode. So this crankshaft is going to go back into the engine today. We did measure runout on this and we did a crack test previously. Dave has a magnetic crack test machine, okay? Trust me, I got told about that right away.
And I'm about to show you a crack. Step into my dark room. Okay.
So if you look, you've got that crack there, and then 180.
Whoa! Every crankshaft you buy from Ford has a DMC code here in the back. It also has the date and the timestamp when the crankshaft was manufactured, and it has the main and big end bearing coding on here. 4 letters for the mains and 6 letters for the big end. You can decode the diameter in micrometers of all these races in here. There is then no need to measure those. When you buy an aftermarket crankshaft out of China, none of that stuff is stamped on there. Then you have the cat in the sack, you gotta measure all this yourself. Plus, you never ever gonna have these shiny bearing races like we have them here. I can see my wife in them mirroring, okay? If she looks inside, she probably sees Dave.
When you buy a replacement engine, you take the flywheel off, you can see if your replacement engine already had an engine failure.
Instead of looking for the number on the block, you just simply look at the crankshaft and you know the manufacturing date of your engine, you know, at least within the hour. And you can decode if it's made during a holiday or during a rainy day or near the weekend, okay? Everybody knows when Larry comes back to work on a Monday morning in the Dagenham plant and Manchester United lost, he's gonna fuck up the next 5 crankshafts because he throws them in the heat treat often way too early before the thing is heated up. He doesn't have the machine turned on for the fillet roll process and other things. And it takes about until noon till he normalizes and everything, and then the crankshafts are good. So avoid those early Monday morning crankshafts, okay? That's when Larry was in a bad mood.
Poor Larry, he always gets it.
Yeah, take my drill with me.
Yes.
Okay, we're gonna do the honing now. Oh my God, what am I gonna hear about that now? Okay, because Dave has that huge honing machine and everything. So I'm gonna do a cleanup hone on this engine, okay? This is not in order to change the diameter. So what I'm using here is a honing brush in the correct diameter, and I'm using honing oil, okay? And I basically soaked my brush in this oil. And then I've done this multiple times, so I kind of have the frequency dialed into my arm, okay? At least as good as Dave's honing machine. And I go full RPM on my drill in the small gear, and then I count. And I go like 10 times, and that's it. I'm not gonna make a big science project out of this, because we're gonna get tons of desktop mechanic comments.
Yes.
And Vera reads them all, okay? I'm gonna clean those two up.
Yes.
Oh, I actually watched a TikTok from Dave, and he's using a brush on his drill, so we're gonna do the same.
Yes.
This one I did better. This one is a little bit steeper. This one is definitely OEM and it's flatter. So I have to still do some adjustment, redo this one and then this one. Oh, look at that. This is beautiful. Look at this one here. Look how nice this looks now.
Yeah. Oh, that looks like OEM.
Okay, and now look at this one. This one is OEM.
Wait a second, I have to turn
Go
it
from
around.
over here.
Yeah.
I want to say it's flatter. Still a little flatter, but it doesn't look as nice.
Yeah, it transports the oil up and down.
Where did you learn that from? And that's it. That's all we do for the honing. There's no reason to go crazy on this.
Before we clean the block is to clean up the cylinder head surface.
So I'm first using a light wire brush. This is brass wire, okay?
So that's after the wire brush?
I got a Scotch-Brite pad mounted to my angle grinder, RPM controlled, and I'm gonna go lightly over this to shine it all up. I'm using a razor blade so I get the big pieces off this way. I don't have to work it as hard with my Scotch-Brite pad.
And yes, we have a tool. He doesn't want to use it.
So I gotta clean out the bolt holes. That's really important. If there's oil inside, it can build up hydraulic pressure when you put the bolts in. Guess who I learned that from? Got all holes clean.
Oh yeah, looking nice.
I'm using a rotary toilet brush to clean out each cylinder. Wow, that is clean, I gotta say. So Dave is not bullshitting you. And I'm using Vera's bathrobe towel.
Oh no, don't use that one.
Why?
Because it has lints. That's what we have the white paper towel for.
Come on, there's less lint on this than in my belly button.
Oh my God.
We use ATF fluid. Wipe it there around one time. It comes out black. It's not clean. Oh my God. Clean. It's all clean.
You are not done cleaning, my good friend.
Well, before we do a final clean on this, we gotta clean the underside.
So that was my idea. So all nice and clean.
Everything is now wire wheeled and I've blown it out with compressed air a lot and brake cleaner. Every single bore, every single thread. And remember, this engine did not have a failure before, so it was clean. Anything in there now got in there from me.
Like on Fabian's core, it was completely filled with chips.
That was bad.
It was a day worth of cleaning. So now we're gonna check the evenness of your cleansing job.
Vera is talking about the flatness from the cylinder.
The flatness, yes, I'm sorry.
Okay.
Theoretically, there are different cylinder head gaskets.
For a fact, there are different cylinder head gaskets based on your piston protrusion. And if you do any kind of machining here and you later on determine your piston protrusion and your correct cylinder head gasket, you won't find one. That's the thing. So that's the final result here. Got this like 15 times clean.
Oh my God, look at that. It's
clean.
It's not clean.
It is clean.
What about the other three?
I got the other three off camera already.
Yes, we're gonna do them on camera.
I don't get any desktop mechanic comments. You didn't fist that right. There we go. So just for giggles, Vera wanted me to check the flatness of the cylinder head. So I got here a precision straight edge, and this is 200ths of a millimeter. And wherever I put this, it's stuck, okay? It's stuck.
So 200ths of a millimeter is 20 microns.
Yes. Yes.
Because he bought a tool, so I might as well want to use it.
Well, I bought it for the cylinder head flatness.
Okay.
Yeah, that's right. So in the first step, I gotta reinstall the squirters, 12 Newton meters.
Yes,
Okay.
and guys, if you forget to install them, you gotta disassemble everything again.
Alright, it's after lunch and now we're gonna do our plastic gauge test with the original bearings out of this engine block. We know we're gonna replace the front number 1 main bearing because we checked that in the previous episode and it had a problem. It is not really cylindrical, it has a conical oil wedge shape. So this bearing gotta go. But for this test, we're still gonna use all OEM bearings because I wanna know how even the oil gap is. And now we're gonna wait for that plane to pass by. I got all bearing races cleaned with Scotch-Brite. I got the oil holes all clean and I got the backside of the bearings also cleaned up with Scotch-Brite. And I have them labeled so I know exactly in what position they were in. Also in this direction. I know exactly how they were in when we took the engine apart. I wanna know if this engine had a chance to run or if it would have died. To put bearings in place, we use ATF, okay? We don't put them in dry. And then I insert them in the original condition and I make sure they are absolutely centered, okay? Every single one, 100% clean. So I gotta get them nicely in the center because they don't have alignment notches. And in my opinion, they are in a good condition. We're gonna use a heavy gear oil. This is a 140 weight gear oil. Because it's going to take us a bit until we start this baby up. Oh, it's so shiny. Look at that.
Drop it in carefully.
Then I realize I got it the wrong way around.
Oh my God.
And I don't want to do any banging on this now. And there it sits. Oh, is that beautiful. And there we go. They clean. Also the backside of the bearings. Really easy.
So while you're cleaning, I'm going to change my battery.
There you go. I'm going to put the plastic gauge into grease here on each main. Okay, so put it right on top. All 4 at once. We do not rotate the crankshaft during the plastic gauge test. That's very important. Okay, right in the center. There we go. We're gonna lubricate them with ATF. Okay. Number 2. So you gotta work precise when you do this. There's like a little arrow on here. And this arrow got to point towards the front. I sprayed them last time already, but we can do this again. And also under the bolt head. These bolts are not the bolts we're going to use to assemble the engine. These are our test bolts. We have an extra set.
We have enough sets of bolts.
Do not use a hammer or anything. I get them nicely wound down. I got to do now 40 Newton meters.
Without the inner bolts?
Without the inner bolts, that's okay.
That's new.
Now we're going to do 90 on the outer bolts. Now you notice that we have not touched the inner bolts. The latest Gen 2 Ford procedure does say to tighten all outer bolts 40, 90 and 45 degree before going to the inner bolts. So now I got everything tightened correctly to the latest spec for the Gen 2 engine. Now I got to open everything back up. I start with the inner bolts in reversed order.
Oh, that work. What did it get me?
Whew. Let me take them off and then you can do all at once, okay? No.
Slow. And messing up your plastic. Oh, I'm still not allowed to show you.
If your woman tells you to go slow, you gotta go slow. Okay. Now you can show the results. So the first one is about 0.04, I would say.
What is it supposed to be?
Okay. 0.027 to 0.063. Number 2. Exactly consistent, exactly the same. Also a little bit bigger than 0.038. Number 3, 0.038, exactly consistent, perfect. Number 4, 0.038 and not quite 0.05. These bearings exactly match perfectly, and the reason is that Ford installs these bearings based on the actual bore sizes of the block and on the actual main sizes of the crankshaft. So they have a selection chart in the plant and it's computer controlled. So when they get the block and the crankshaft, the machine automatically selects the exactly correct bearing setup. So they have different bottoms and different top ends. If you buy aftermarket bearings, they are just one size. I'm still out of breath because it was so much work to pull those bearings out. So this is an extremely good result.
Yes.
But what does suck is that the front bearing in our previous episode was diagnosed as being non-cylindrical. Yeah, it even looks like it's in this area of the bearing, it's wider, and in this area, it's narrower, okay?
You can see that.
What we do now for documentation is taking a picture of each main bearing, because without the proper documentation, an engine rebuild is worse crap.
Yes.
Okay? Especially for a German. A German gotta document everything.
We're gonna have to do another plastic gauge test with a new bearing we install here.
Okay, so I take a picture here. Also note that we use the English plastic gauge test, okay? British made, it says it right on here. That one always gives you good readings on a Land Rover engine. If you use the American style made one like this, it always gives you bad readings, okay? It doesn't work, it's not compatible. The English got kicked out a long time ago out of the country, and that's why you gotta use the English plastic gauge test. See, it doesn't say made in the UK, it says British made.
Even though it's a Ford, it's made in Dagenham.
So we're finished with this test and it's a really good result. But like Vera said, we're gonna have to redo bearing number 1. Take this baby back out.
Yeah, he's gonna hurt himself.
Take that baby back out. What the hell?
What the hell? Did you forget?
It's stuck in the oil. So we're gonna redo the test now with one king bearing in the front because we're not happy with the shape of our OEM bearing. Okay, so this bearing fits nicely in here. Yeah, the oil hole is much bigger, see that?
Oh yeah.
I do trust Ford to be able to measure and design the oil distribution in an engine like that, and then if an aftermarket supplier goes there and just makes a hole bigger, I think that's a pretty dumb idea.
Yeah, but why did they do that?
It is a marketing thing for them, okay? People say, oh, the bearings don't get enough oil, and then the marketing manager just goes there, well, let's make the oil hole bigger, and they're all gonna be happy, and we're gonna sell millions of bearings.
Well, we have used them many times now, and we haven't had any.
We have not had a king bearing fail so far, that's true, but we didn't do a ton of engines.
The good thing is, if the plastic gauge test is good, you don't have to take it out again. So you guys should know the drill by now. Same procedure in the opposite directions.
Okay. And gaps tighter. So it's not 0.025, but it's about 0.038, just like that. So you can also see that this bearing is now nice and cylindrical, okay? Yep. The other one was kind of like an eye drop shape. Perfect. So we're gonna use the king bearing in the front. The only downside is that the marketing manager had king drill open the hole to a bigger size. That kind of sucks, okay? Are we gonna get comments now? Why didn't you use this bearing and that bearing? Yes, there are multiple different bearings on the market, but the problem is that some of those manufacturers do not state any dimensions in their catalog, and you really buy the cat in the sack. That's one problem. The second problem is that, remember, the block and the crankshaft is in the factory matched to a bearing selection. They have different bearings. If you now buy generic bearings, even the king bearings, you basically need some luck that they match up to your crankshaft and to your block. In our case, they did. But Ford even installs the crankshafts if they are up to 10 microns out, positive or negative, and that's when they start to match their bearings. And if you get one of those crankshafts and you match that with a block, you can be right off the back 0.01 too much gap or too little gap. And then if you have that mated up with a block in a certain tolerance, then you won't have a good gap. That's why a plastic gauge test on this engine, or an equivalent test where you measure the bores with the bearings installed, some engine builders do it that way because plastic gauge is not as accurate. It's really important to have that test done on this block, or you have later on running a cat in the sack. And a cat in the sack don't live long.
So he's gonna take his final pictures?
So she needs to go right now to do something more important than assembling my engine. And I'm gonna do the final install of the crankshaft with you guys together.
And don't mess up.
Okay, but you're not taking my queen.
No, I take the mothership.
See you later. I think it is the best maintained Discovery in Germany. So you can see when Vera is gone, I'm replacing her with this device. The only problem is it doesn't tell me when I screw up. So I'm putting away my plastic gauge test bolts. They are only used for that and for nothing else. I would never install these multiple used bolts for final torque. Perfectly clean crankshaft. Lubricate the top of the crankshaft now. Heavy gear oil. Lubricate the main bearings with heavy gear oil. These are now the original bolts from this engine. They can be tightened up to 3 times. Bearing number 2. Jesus. Luckily Vera isn't around. Now in the final torque procedure, it's important to leave the bearing block number 4 loose here. Now I got to do the outer bolts of bearing 1 to 3 with 40 Newton meters. Leave bearing block number 4 alone. 45 degrees. Leave bearing block number 4 alone. Inner bolts bearing block 1 to 3 with 40 Newton meters. Same ones with 90 Newton meters. 45 degrees. Now we got to do bearing block 1 to 3 outer bolts another 45 degrees. And inner bolts. And done with bearing number 1 to 3. Now I'm using a crowbar to bring thrust against the crankshaft towards the front, and in this condition I seat the outer bolts. There we go. That should have aligned the crankshaft for the correct axial float. Oh, look who is back. Okay, but you've been replaced. Now I gotta do the outer bolts. Outer bolts was 90. And in this condition I can already check end float before I finish it. .28. When we took the engine apart on the 20th of April, it was 0.3. Now we got 0.28, so this is really a good result. Yeah.
So it's still in spec.
0.21 to 0.43.
Oh.
So we're right in the middle. Well, I just noticed for that force bearing, I should have tightened the inner bolts first and then the outer. But I think because we got the correct end float and all the others were outer first, we should be okay. Maybe it's a typo in the manual. So 40 Newton meters on the inner ones. We gotta find that.
Oh my god.
Okay, that's it. Crankshaft is fully installed. Now we can do torque to rotate, and then we better find our little lever from the torque wrench.
No. We are doing the lever first now.
Yeah, let's look for it. So we got a little bit of a debacle because on our torque wrench there is this plastic piece here missing on the back side. And I'm pretty sure that was on this morning when I started the job. I'm gonna be able to see that in the video, I'm pretty sure. And now it's gone, so of course, what does everybody think? That we left it in the patient, okay? And now we get ready to sew it all up. That would be really bad, but I looked, it's not in there, okay? It would be also fairly obvious, so I think it may have just fallen down and we kicked it around and we're gonna find it at one point. I sweeped everything. And it's definitely not in the dust we had in here. And this place, I know it doesn't look like it, but this place is extremely clean, okay? Okay, so it really sucks that this piece is gone. Not only because the torque wrench is now rendered useless, a tool shouldn't lose a piece like that. That's a bad design, okay? That's like a Range Rover losing a piston ring, which happens. So they get 40 Newton meter in the first stage. Then they get 45 degrees. So just to complete the crankshaft install, we're gonna do a torque to rotate, and the specification is 3 Newton meters, excluding breakaway torque. Here you can see a black line with 3 Newton meters, and I want that crankshaft to rotate.
Beautiful.
So we have 1 Newton meter.
Oh my god.
So this is really good, and that's a sign that nothing is stuck. We got that done, and this value actually goes into our Excel table. 1 Newton meter of rotate torque.
So you guys notice with our new camera, the DJI Osmo Action 4, there's no light flickering anymore.
Torque to rotate is really good, as you saw. Nothing is binding up. But before we end the video here, I do want to comment on all the comments we got again in the last recent videos. Why don't you just drive a Toyota, okay? And the thing is, I actually believe those comments are not coming from Toyota drivers. I think they come in from people who are just overwhelmed with the amount of maintenance we do. But I do want to answer why we don't drive a Toyota. I answered this in videos before. And for us, it's an emotional thing, okay? A Toyota does not get my emotions. It doesn't grab it. There is nothing exciting when you drive down the road in your Toyota and you go like, oh, I gonna get to the end. It's not gonna break down. I gonna drive to A and to B and then back without a failure. There isn't anything emotional. Versus when you drive a Land Rover, it's like a drug. And it doesn't matter which one you drive. You can drive a small Freelander and that's like the entry truck, okay? That's like when you smoke weed and you go like, geez, this baby feels good. Maybe we want to try something stronger, okay? And then it goes on. You may upgrade at one point to a Discovery, and that's already like alcohol level, okay? You can drink a lot of it before people realize you are addicted, and it can go for a long time. That's your long-term drug, and it's the kind of drug where you don't realize that you are addicted, and the car just goes and goes. And people go, well, are you kind of addicted to your car? You know, you put so much money in, and you go like, oh no, I'm not addicted. I only like do it once a day. And at one point when you are addicted to Land Rover, you may hook up to the bigger drugs, okay? You want to get to cocaine. That's the Range Rover and the Range Rover Sport in the V8 versions, okay? And those things will really pull you down. They will really ruin your life long term. But because you are addicted, you're not going to be able to disconnect from those vehicles again. It will go on, and at one point you're gonna start with crack, okay? You're gonna get the supercharged V8, and that's when you start losing your teeth and everything. So that's what Land Rover driving means, and that kind of an emotion you never ever gonna get out of a Toyota. And at that point I want to thank our Patreons a lot for their support, and
we'll see you next Sunday.
Oh, and not that I know anything about those substances.
Yeah, Christian doesn't even drink alcohol. Look at that beautiful collection, and I actually want one more out of a broken engine coming out of a F-150. But they are hard to get here in Germany.
Oh, but so far there are only three 3-liter F-150s for sale in Germany, and they're not broken. What the hell? Starting to build like reliable engines.
That poor Mercedes. It was slipping all the way from... Oh my god. Oh. You guys not gonna believe what goes on top of this thing. Look at the size of this thing. 400mm diameter wheels on it. Jesus.
So we put it on that now?
I actually carried with Robin the grinder down, okay? But now I'm disabled for about 8 weeks. So now the kids have to do it. This is another device which is not going to be movable. In the first stage it starts on star and then you shift over to triangle. So watch it. I got the responsibility.
Oh, it's really quiet and there's no unbalance.
Yeah, but well, there's quite a run out. So Robin, we have to fix that run out. And the thing even got coolant here, okay? It got a coolant pump and a coolant reservoir, so you can run ceramics on here.
I thought it's gonna jump around because it's so old.